Hello everybody, today I'm gonna make short practical video in spanning tree protocol, and this video is gonna be designated to building STP topology. In today's video I'm gonna review and show in practice some key elements of spanning tree protocol, like port states, port types, timers, default interface STP port cost, root path cost, and some other interesting features of spanning tree protocol. I'm going to use the following topology, which consists of 5 switches and 2 hosts. And in my topology is going to be 3 VLANs configured on each switch, VLAN 1, VLAN 10, and VLAN 20. So let's get started. Okay, here we have our topology. We have 5 switches, and let's get started. I've already pre-configured VLANs on all switches. For example, you can see that on switch 1 we have 2 VLANs. Let's say switch 3, we have also 2 VLANs, 10 and 20 here. And let's say switch 5. Switch 5 has also 2 additional VLANs pre-configured. And all interfaces between switches are trunk ports, so interface trunk. This is switch 5. We can see that 3 interfaces are trunks, and for example switch 1. Switch 1 has also 2 interfaces as trunk ports. Then let's see what about spanning tree. So spanning tree. For spanning tree, we have 802.1d STP running, and this is IEEE in the output of show spanning tree command. You can see it. And we have timers, default timers configured 2 seconds for hello timer, 20 seconds for max age, and forward delay is 15 seconds. Let's see, let's try to change timers. So spanning tree, then we need to go for VLAN, for which we want to change. Actually, let's see what options we have. We have all these options, but this is not about our timers. Then we go for VLAN, and let's say we want to change for all our VLANs, VLAN 1, VLAN 10, and VLAN 20. Then we have option which timer we want. We want hello timer. And we can change it from 1 to 10. Let's say it's going to be 10 seconds. Now options, we go for it. And show spanning tree. And we can see that now our hello timer is 10 seconds. Let's go and try to change max age timer. Max age timer should be greater than hello time, because switch is waiting for max age seconds before it starts changing topology if it hasn't got any hello BPDUs from root bridge. And let's go and change it. Spanning tree, VLAN 1, 10, 20, max age. And you can change it from 6 to 40 seconds. For example, if you forgot and you want to change it for time less than hello timer, system 6, sorry, system will not give you to do this. You will get error. Max age has to be bigger than hello time to be useful. So let's change our max age timer to, for example, 15 seconds. And to show spanning tree, we can see that max age timer is 15 seconds now. And let's go for forward delay. Forward delay, and we can change it from 4 to 30. Let's try, for example, 4, if system will allow us to do it. Yes, it's working, but I'm gonna stick with, for example, 12. Spanning 3. And as you can see, forward delay has been changed. Let's go, for example, to switch 3 and see what's going on for spanning 3 over here. And we can see that root bridge is switch with MAC address 5E and all zeros, which is our switch number 1. And this one has hello time 10 seconds, max age 15 seconds, and forward delay 12 seconds, as we configured just recently. And local timers are configured by default to 2 seconds, 20 seconds, and 50 seconds. These timers are gonna work only when this switch becomes root bridge, in case. Okay, and let's see, for example, I want to see our BPDUs. So we're gonna go to debug, spanning 3, and we have options. I'm gonna use BPDU. Let's wait a little bit until I receive BPDUs. Okay, we can see incoming BPDUs from ports for each VLAN. I need to undebug. Debug, and let's pick up, for example, this for VLAN 10, this BPDU. I just paused the video to copy this BPDU in this slide so we can go through it and discuss and compare to our BPDU format for STP. This is BPDU format. So first we have 4 zeros, and these 4 zeros is protocol identifier, which is 0 on the BPDU. Now we have, next one we have 2 zeros. 2 zeros is the version, and 2 zeros for version is STP. Next 2 zeros, message type, and this is configuration BPDU. And the last 2 zeros is flag, and we can see that the flag is not set because now we have zeros. Next one is our root ID. Root ID starts from the priority, then it adds some, like here we can see. Bridge priority 8, and this is the highest bit set. It corresponds to 32,768. Then we have system extension ID or our VLAN. It is A, and A in hexadecimal is 10 is decimal, so it's for our VLAN 10. And then last one is the MAC address of our root bridge. Next is 8. 8 is root pass cost, and let me show you on the topology. So we got the root pass cost 8, and when we can see we received this BPDU on interface G11, and it's coming from switch 4, then switch 2, and then from the root bridge. When switch 2 receives BPDU, it has pass cost 0. Then switch 2 adds its interface cost, which is 4 for gigabit internet, and sends it to switch 4. Switch 0 receives this BPDU and with root pass cost 4 and adds its own interface cost, which is 4. And we got 8. Then switch 4 sends to switch 5, and we got root pass cost 8. Okay, after root pass cost, we have bridge ID. Bridge ID, this one is our designated bridge, which is SW4, which is sending this BPDU because we received it in interface G11, and this interface G11 is facing to switch SW4. And we can see that 8, the same bridge priority corresponds to 32,768 because I left all priorities by default. A is our VLAN 10, and then we have MAC address of our designated bridge, which is 5E00003000. Then we have port ID. Port ID first number is 8, and it is the highest bit set in port priority, and it corresponds to 128. And port number is 7. This is port number from the sending switch or from our designated switch, and let's see on the topology. So switch 5 received this BPDU on its interface G11, and it was sent from switch 4 from the interface G12. And if we go to switch 4, and we can see that G12 has priority 128 and port number 7. So our port ID 8007, port ID priority 128 and port number 7, as we just seen. Next one is message age. The message age is 02, and 02 shows that this BPDU was forwarded by 2 switches. Whenever a switch forwards BPDU, it adds 1 to message age. Next one is maximum age or max age timer. This is F, and if you remember, we changed it to max age 15 seconds. This is 15 seconds, F 15 in hexadecimal. Next one is hello timer. Hello timer I changed to 10, and A is 10 in hexadecimal. You can see. And the last one is forward delay. Forward delay I changed to 12, and C is 12 in hexadecimal format. Let's get back to our topology. Shows spanning tree. Our timers are still the same. Hello timer 10, max age 15, and forward delay 12 seconds. And I want to show you one more way how to change timers. And with this command you can change it to recommended by Cisco depending on the diameter of your network or maximum number of bridges between any 2 points of attachment of end station. Actually, like how many depending on the how many switches you have between your end stations. And this is gonna be spanning tree VLAN 1, 10, 20. We need to use root primary, and we are making our switch at the root primary switch for these VLANs. And then we have option diameter, and by default this option is set to 7. Let's go for 7. Do show span, and we can see that our timers are changed, and they are back to default ones: 2 seconds, 20 seconds, and 15 seconds. Let's go for 2. Show span, and we can see that now we have 2 seconds, 10 seconds, and 7 seconds. So this is also a useful option how to change your timers. Now I want to show you transition times for port states to listening to learning states, and we're gonna do it the debug spanning tree, and then we have option events. On switch 5 we have G03 as root port, and it's in forwarding state, and these 2 ports, they are in block state, in blocking. And if I want to disable G03, and if I disable G03, this interface G10 is gonna be a root port because it's receiving BPDUs from G11, which has less port number comparing to G12. And these 2, they have the same port priority. I just want to show you this. Enable Cisco, show spanning tree, and you can see that they have the same priority, but port number G11 has less port number, which is 6. And now conf t interface G03, and I'm gonna disable or shut down. And now we see that this port immediately changed to listening state, and then it went to learning state, and then it went to forwarding state. Show spanning tree. We see that our forward delay is 7 seconds, and we can check. For example, listening 22, then it changed to learning 29. 29 minus 22 is 7 seconds, and then it changed to forwarding 36 minus 29, 7 seconds. So forward delay is the parameter or number when how many seconds the port needs to stay in interim state, like listening and learning, before it goes for forwarding state. Okay, and now I want to show a few useful commands. So spanning tree, you already know it. And I want to, for example, filter by, I don't want to see all information, like for all VLANs from this output. I just want to go show spanning tree for VLAN, for example, 10. And it's gonna give you only information for VLAN 10. You can also notice different root ID priority in the output of this command. If the default value is 32,768, here we have 24,586. And you can see that 24,576 actually, because this is VLAN 1 is 77. This happened when I issued this command spanning tree VLAN 1 10 20 root VLAN 1 10 20 root primary. And then I added when I issued this command to show you how to change timers for diameter, it sets root primary sets priority for the switch to 24,576, and if you want, for example, you can make another switch root secondary spanning tree VLAN 1 10 20. I'm gonna make switch to secondary root bridge root secondary. And if you check, then it's gonna set bridge priority to 28,672. Let's see. Yes, 24,672 plus 1, 73 plus 1 for VLAN 1. Next, I wanted to show spanning tree and then root. This command will give you root IDs for each VLAN. For example, for VLAN 1 we have root ID 24,577 and MAC address of the root bridge. We have root cost 12, we have hello time 2, max age 10, and forward delay 7, which is set on the root bridge. This is actually for root bridge, to see which MAC address is for root bridge and what is configured for this specific VLAN, which timer is configured on the root bridge. The other one is show spanning tree interface G10, and we can see status of VLANs on this specific interface. We can see that for VLAN, for status of the port for a specific VLAN, and we can see that for VLAN 1 is forwarding, for VLAN 10 forwarding, and for VLAN 20 forwarding. We can also find the priority of the ports and type of this interface. And there is one more option for this command, is detail. This output gives you more detailed information for spanning tree. For example, you can see that this is this interface for VLAN 1 is in forwarding, port cost 4 which is 4 gigabit Ethernet, port priority 128, which is default port identifier 128.5. This is our root bridge 24,576, actually 2077 for VLAN 1, MAC address of root bridge, and this is designated bridge, which is our SW4 for this SW5, and it has priority 3,769 for VLAN 1 and MAC address, and we can see from which port we're receiving this BPDUs. This is gonna be G11. Let's go and check. Show spanning tree, and we can see that G11 has port ID 128.6, and we can find it, yes, designated port ID 128.6. Designated pass cost is 8, which is pass cost from this switch SW4 to the root, 4 plus 4. And one more thing in this output is sent BPDU and received BPDU, number of received and sent BPDUs. And the last one, as you noticed, I have a host on this switch SW5. And if you have, for example, ports on the switch have types P2P if we have a network device on the other end of the link, or it's gonna be P2P edge if we have host and the interface is configured to port fast. Show run interface G01, and we can see this interface G01 is configured like access for VLAN 10, and this is in this interface in port fast. And for example, on switch 4, let's go and check switch 4 because we have also host here, and show run interface G01. Here we don't have port fast configured, and show run interface, show spanning tree VLAN 20. And as you can see, there is no P2P edge, so I'm gonna go and do it. Interface G01 spanning tree port fast. And let's check. Yes, and now it's P2P edge. So this is all I wanted to show today. Thank you very much for your attention. Thank you very much for watching my video. If you liked it, you can subscribe to my channel. And in the future, I'm going to continue to making videos. Next video is going to be also about spanning tree. So one more time, thank you very much. I hope to see you soon. Ciao, ciao.